Our modern gadgets, from smartphones to laptops, rely on a complex cocktail of raw materials. Silicon, the backbone of modern electronics, is relatively abundant. However, extracting and processing it requires vast amounts of energy and water. Furthermore, these devices depend on a range of rare earth metals with much less glamorous names. These metals, such as tantalum, yttrium, and neodymium, play critical roles in everything from displays and batteries to speakers and circuitry. The demand for these materials has skyrocketed in recent decades, driven by the insatiable global appetite for new technology. This surge in demand has placed immense pressure on the environments where these materials are mined and processed. Often these mining operations are located in countries with lax environmental regulations, further exacerbating the ecological damage. The consequences of this unsustainable resource extraction are significant and far-reaching. Mining for the raw materials in our gadgets leaves a heavy footprint on the planet. Deforestation is a common side effect as vast tracts of land are cleared to access mineral deposits. This habitat destruction threatens biodiversity and disrupts delicate ecosystems. Moreover, mining operations often contaminate water sources with heavy metals and other toxins. These pollutants can leach into groundwater, poisoning drinking water supplies and harming aquatic life. The manufacturing process itself is also energy-intensive, contributing to greenhouse gas emissions and climate change. From the extraction of raw materials to the assembly of finished products, each stage of the production chain requires significant energy inputs. The transportation of these materials and products around the globe further adds to the carbon footprint of our gadgets. As the demand for technology continues to grow, so too will the environmental consequences unless we find more sustainable ways to produce and consume these devices. Faced with these challenges, the tech industry must innovate to reduce its environmental impact. One promising avenue is the development of new materials that are less environmentally damaging to extract and process. Organic semiconductors, for example, offer a potential alternative to traditional silicon-based electronics. These materials, derived from carbon-based molecules, can be synthesized using less energy and fewer toxic chemicals. Moreover, they offer the potential for biodegradable electronics, reducing the problem of e-waste. Another crucial step is to improve the recyclability of electronic devices. Currently, a staggering amount of e-waste ends up in landfills, where toxic materials can leach into the environment. By designing products for disassembly and using more easily recyclable materials, we can create a more circular economy for electronics. This will require collaboration between manufacturers, policymakers, and consumers to establish effective recycling programs and incentivize responsible disposal. As consumers, we also have a role to play in promoting sustainable tech practices. By making informed choices about the products we buy, we can encourage the industry to move towards more sustainable solutions. Opting for devices with recycled materials, supporting companies with strong environmental track records, and extending the lifespan of our gadgets by repairing them instead of immediately replacing them are all steps in the right direction. Our insatiable appetite for the latest and greatest gadgets has come at a cost. The environmental impact of our tech consumption is significant, but not insurmountable. By embracing innovation, promoting circularity, and making conscious choices, we can create a more sustainable future for both the tech industry and the planet. The responsibility lies with each of us to demand and support sustainable practices, ensuring that our technological advancements do not come at the expense of the environment. Only then can we truly enjoy the benefits of technology without compromising the health of our planet for future generations.